Alright, we're going to be taking the derivative of some log functions. We have the function here f of x is equal to log of x to the fourth plus 4x plus 7. So this is much like the derivative of the natural log, except we got to do something a little bit different, but not much. So this is kind of the setup here. Now let me just add something here. Sometimes you see a number right here, and if there's not a number right here, this pretty much means that log has base 10. Log has base 10. If nothing's here, log has base 10. But this is what we're going to be following. So we take the derivative of what's in parentheses, the derivative of that r of x, and then you just rewrite it down here in the bottom. But the additional part was, now we do the times the natural log of whatever that base log was, and it was log 10, base 10. So then you just say the natural log of 10. So the derivative, what's in parentheses first, so the derivative of x to the fourth is going to be, bring the 4 member out front. So the derivative of x to the fourth is 4x cubed plus 4. Alright, derivative of 7, 0. So you got 4x cubed plus 4. Alright, so we write that in the numerator, and then you just rewrite everything times the natural log of 10. That was the base. Now, remember the natural log functions where we were taking the derivative of them, but we didn't write this natural log of 10 down here. The base of the natural log function has base e. And if we said the natural log of e, well, the natural log of e is just 1. So that's the reason we don't even bother even writing this in here when we are taking the derivative of some natural log functions. Okay, so the next one here we have 5. We have f of x is equal to log base 5 of x. So we take the derivative of what's in parentheses, and derivative of x is 1. And then we just rewrite what's in parentheses down here in the denominator. And then we say, right, the natural log of whatever this base is, and this happens to be base 5. And in the previous problem, remember, it was nothing was written here, and that implied that this is a 10. But so it's not too bad. We have f of x is equal to log base 3 of x cubed over x minus 1. First thing I'm going to do is I'm going to break this up. You definitely do not want to do be taking the derivative of this. That means a quotient rule is just nasty, right? So let's break it up first and then take the derivative of each one of these separately, right? Fraction means minus sign. So and then looks like I do one other step here. I take this 3 and bring it out front. Hey, this is just the properties of logs now. We're not taking the derivative yet. So take the 3 out front. Now it's broken down completely, and we can now take the derivative of it. So the derivative of x is 1. Rewriting what's in parentheses, put it down here in the denominator, and then this is the natural log of the base, natural log of 3, minus, and then taking the derivative of x minus 1, which is just 1, rewriting what's in parentheses, and the natural log of 3. Okay, I go ahead and get this all into one single fraction, which means we're going to have common denominator. So I don't have an x minus 1 over here, so I write 1 here, but I got to put 1 in the numerator also. We don't have an x over here. I put 1 over here. We do have a natural log of 3 over here and a natural log of 3 over here, so we don't have to do anything with that. Now I want to simplify this down. So we have 3 times the x minus 1 minus, right, this is 1 times x. I distribute the 3 across. And it looks like simplifies down to this, and I believe I stopped right there. So, and that's supposed to say f prime of x. Oh my gosh. Sorry about that if any of these other problems don't say f prime of x. That should say f prime of x, f prime of x. Alright, it says it now. If you happen to find some of these other problems that maybe I've done something like that, please let me know. Wow. Okay, thanks. Bye. We are taking derivatives of log functions. So we have the function here, f of x is equal to log base 4, and in parentheses x plus 1 over x minus 1. So the first thing I'm going to do is I'm going to break this up, or expand it. So I write this as log base 4x plus 1 minus log base 4 of x minus 1. We take the derivative of x plus 1, which is 1, then we rewrite what's in parentheses, and then we say the natural log of whatever the base is here. So this would be the natural log of 4 minus, and then we do the same thing over here. So the derivative of x minus 1 is just 1, and hopefully we know why, right? Derivative of constant 0, and derivative of x has a power of 1 here. So we bring the 1 out front, we subtract 1 from the exponent, so therefore you get x to the 0. And x to the 0 is just 1. And 1 times 1 is 1. So that's the reason there's a 1 there. I don't know. I just went through all that. Whatever. Alright. Now what I'm going to do here is I'm going to join both of these together, get one single fraction, and because we don't have an x minus 1 over here, I put 1 here, and I put 1 up in the numerator. And we don't have an x plus 1 down here in the denominator for this fraction, so I put an x plus 1, but I also put 1 in the numerator. And then we just multiply 1 times x minus 1 and 1 times x plus 1. Alright, and I distributed this minus across here. So that's the reason there's a minus here. X's cancel out, you're left with negative 2, except I bring the negative out here in the front. We have f of t is equal to t squared log base 6 of t plus 1. We're going to take the derivative of t squared first. We're using the product rule. That is, we take the derivative of this first function first. So derivative of t squared is 2t. Rewriting the second function plus, and then I rewrite t squared times, and then the derivative of log 6 t plus 1. So the derivative of t plus 1 is 1. We rewrite what's in parentheses, and we take the natural log of whatever the base of is, and that happens to be 6. Now I'm going to get this, maybe, what am I going to do here? I might simplify it. Let's see, I don't do anything here, and I just took the t squared and took it up into the numerator. Yeah, I think I give you a break on this one. Anyway, and that's as far as I went. So, alright, hopefully that instead of trying to learn this stuff passively, and that means you're just sitting back with a soft drink in your hand, just kick back, feet up on the desk, or wherever your feet might be. Anyway, you need to really be pushing a pen on a piece of paper and writing this stuff down. That really helps you memorize it. Now, did I say pen? Yes, I did say pen, and I remember that I used a pencil when studying math for, I think, up until calculus, maybe the halfway in the semester of calculus, and then I got rid of the pencil and started using a pen. And there's reasons for that. And the big reason is a pencil will condition you to do nothing but make mistakes where you have to go back and erase. A pen helps you not make those mistakes. I was once helping a lady, and she was considerably older than me, but and she had this great big huge eraser, and she was using a pencil, and she would write about 2 lines or so, a line or whatever, and she would grab that big eraser and start erasing, and throw the eraser away. I guess you can use a pencil, just don't use the eraser. But pens really, I think, help you to get away from that idea of, hey, I made a mistake and now I'm going to erase it. Another thing about using a pen, you just draw a line through it. That still records. You can go back and see the mistake that you made. So that's my philosophy on using pens and pencils. Anyway, all right, bye.